Greetings and salutations and welcome to the event video. In today's video we're going to be covering a beginner's guide to hardware and inventor and how to make the best computer, workstation, whatever for your money. So let's get into it. So this video, I'm going to say out loud, I am not a professional. I don't suit like businesses out with hardware, but I have a reasonable amount of experience with it. I've built my own computer, I've built others' computers, and I'm very much keeping up to date. I also use a lot of this thread a lot, and I get a lot of my knowledge from other people as well, so kudos goes out to Neil from TFI who shared a lot of his knowledge out on his YouTube. This is more to bring it more up to date with current hardware, so just use this as kind of a basis and use benchmarks and actual concrete data as evidence for your support and actually how to get the best performance. Now with that out of the way, let's get to it. So yeah, this is based on how fast is your Inventor PC really, which is, this is a huge thread, thousands of replies and posts where people ask questions. We put our benchmarks up. We use Inventor Bench, which is really good because it specifically tests how good your computer is at Inventor, which is the most important thing. So let's go into what are the actual criteria. So Inventor, if you don't know, is actually single threaded in most cases. There are very few cases where it is multi-core. And they're like very specific here, drawing views, certain graphics, some workflows, but that's not most of the time. Most of the time you're going to be relying on one core, and so it makes sense, and it actually benefits from the core being as fast as it possibly can be. And so we're going to talk about the CPU first. And so if you go on to Intel, you kind of have two choices. You can go with consumer, or you can go on with business. On the consumer side, you have Core series, which is then split down further into consumer and prosumer or enthusiast range. So your consumer range is your I series, so your i7s, i5, i3, i7, i9, etc. Enthusiast are your X series. These generally have like better power delivery, more cores, more PCI lanes that allow you to connect more devices. So if you need more lanes, then go with a enthusiast. If you don't, then just go with the Core series, like the Core i9, the ones I've just got up here on this ARC page. For those who don't know, ARC is Intel's database because their naming system and they make so many processors is so complicated. So just go on here and look it up. So you see, just go on to, I just went on to 9th gen, Core i9, and the main thing you're looking for is the fast turbo frequency. And so you can see here, pretty much most of the time you can go and get 5 gigahertz out the door. It helps to have a bit of a higher base frequency, so out of all of these here, you'd want to make sure you've got the 9900 KS, because 2.4 on all cores is just going to hinder you in other processes. So, but the 9900 KS is also good, and furthermore, it's overclockable. So if you want to have a bit more speed and you have adequate cooling, your office or your space is cool, then you can get a bit more performance out of it. But say you want more reliability, say your name is really on the line and you need to keep the office out that needs to be as reliable as possible, well then look no further than the Xeon line. Xeons are designed for like demanding reliability, and they have a lot more feature sets to go with it. Like Xeons, compared to Core series, have ECC memory, which is a type of memory that prevents data corruption by having a parity bit. Look it up if you want more info about it. It also has other things like trusted execution, so it's more secure, and just other more business things that a consumer won't use. And so if you look at the Xeon E-Class, which is these processors here, and you literally just want to go the fastest you can get, like, look into them. But obviously you gotta look at, so you see here we can look here, we can get like a 4.94 gigahertz overall. And you see you can click onto it further, and you see, so you get in 6 cores, 12 threads, which is pretty much plenty. I run a hexacore and it has served me fine. It's couple generations, it's a 7800X, but overall serves really well. So yeah, just make sure if you can get hyper-threading, it's pretty useful to have outside of CAD. So if you're doing other rendering, it just kind of makes multitasking a little bit easier, trying to put it simply, because it's not the simplest things to explain. But generally, you want a lot of speed on and the turbo frequency. Your base clock, less concerned, but it's always helpful to have a high one. So given the choice to have the same turbo, go for the higher base frequency. Turbo, by the way, is generally 1 core, possibly 2 cores, so it's the fastest a core will go. Do bear in mind this is dependent on other things like power draw and thermals. So if it gets too hot, it will actually scale itself back to preserve itself and reach something called T-junction. Whereas if it's not, if you've got plenty of cooling, if you've got like a water cooler or you're more extreme and you've got a good power supply, it's getting plenty of power, then obviously it can go up to and stretch its legs as high as it can. So that's it with processors. The other thing to note with Xeons, if I go into Xeon, avoid scalable like the Black Death. These things are terrible for Inventor. If it's actually going to let me work, if it's actually going to load. Xeon scalables are terrible because they have many cores which Inventor can't use, and they're very slow. They're scalable because you can put many of them into a board. So if I then just go, let's go to arc.intel.com. Oh joys, it's gone unresponsive. Okay, processors, Xeons, scalable. If it has a metal in the name, avoid it like the Black Death. They're just terrible. Look, you see, like they go down to like 2.6. It's not 1.8. It's like just not even beneficial, and it's got so many cores. Like Inventor will never ever use it, except like unless I think it's even like rendering or ray tracing. But even then, you do that so little of the time, it's not even worth it. Okay, so next job, let's go into GPU. So this I'm going to look at more NVIDIA. You can obviously look into AMD. I'm not going to say you can also look into AMD for your CPUs, but obviously with AMD, have been not so prolific in the actual workstation industry for as long, whereas Intel has been known to dominate there. So I don't actually have many benchmarks. I haven't seen many benchmarks with the AMD. So try them out, have a look, get some data. Obviously, this is more just like kind of like my insight and my opinion. So you go to NVIDIA, you've got two types. You've got the prosumer Quadro, and you've got the consumer GeForce. Effectively, on a card-for-card basis, they are pretty much, if not the same. So inside a graphics card and inside a CPU, you have the main processing chip. In a graphics card, you have what's called the GPU chip. And so if we take the TU104, which is the Turing 104 processor, you can see here it's in the 2060, the 2070, the 2080, and the RTX 4000. So you see you've got the Quadro and you've got the RTX. Both have 8 gigs. Both have a similar-ish amount here. They've obviously been binned and trimmed down, but very much the stats will be very, very similar and the performance will be very, very similar. Obviously, there'll be adjustments. Quadros cost a lot more, and obviously you've got to compare them. They also can have more RAM, or more VRAM in particular. And the thing is with Inventor, you can completely ignore your GPU except for memory. 4 to 6 gigs, more than enough. Any higher than that, and it's just wasting your money because GPUs get very expensive at the high end. If you have 8 gigs, I have an RTX 2070, so that'll be fine. The actual GPU rarely ever goes on. It just gets filled up with VRAM from like textures, etc. If you run 4K, you would obviously need more close to 8, but don't use CAD at 4K, just it unnecessarily bottlenecks it. So yeah. Quadros, on the other hand, just have benefits like ECC VRAM and have like support for Mosaic and just more stability orientated. They're also made directly by NVIDIA, so NVIDIA directly controls the quality of Quadros, whereas GeForce, the chips are sent out to board partners and board partners doesn't matter. So every Quadro RTX 4000 is the same, but a GTX 2070 can vary quite a bit from partner to partner. Okay, and so if I go into desktop process for AMD, not too much to say here apart from their speeds aren't as high as Intel. Whether they're on catch-up, I don't know, but we'll yet to see more from AMD. They are doing pretty well in gaming, but so far I haven't seen so much in the actual like pro line, because like even if you go down like to business, you go to Ryzen Pro and Ryzen Pro processors with graphics. When it loads, guys, like specs, you see looking at 4.3, 4.4, 4.2, 3.8, and we're hitting 5 across Intel. But most of the time you're hitting way more cores than you need anyway. So that's kind of it for processors and cards. So for now, let's go through the system builder. We've done CPU. Cooler, just get what you can. I advocate for Noctua, but if you like water cooling, it's up to you how quiet you want your system to be. Motherboard, ultimately, whatever you want, whatever fits in your case, as long as it has the connectivity and the socket is the same size. Memory, if you have a core series, go for just non-ECC standard memory. Faster makes minimal difference, but if you want faster, you can go for faster. Generally more than 16, 32 is usually more than enough. Obviously add more RAM as you have slots, and just make sure you have the correct configuration. But obviously look, you have to do more research into it. Storage splits down into two categories: hot storage and cold storage. Hot storage is more what's going to be used on a day-to-day basis. Please make an SSD, especially if it's an NVMe like a Samsung 970 Evo, or even if you go for Intel Optane. Just so much storage, blazing fast. Intel and your OS will boot up so much faster and you can be so much more productive. Hard drive, great for archival, great for if you need to store a lot of things or old projects, but not so good if you want a fast access. Video card, bin over, case doesn't really matter. Power supply, as long as it's not some dodgy Chinese one, or it's pretty reliable. I have a Corsair HX750i, it works a treat. But obviously you got Corsair, EVGA, Be Quiet, there are plenty out there. Just make sure it's a reputable brand. Optical drive, who use them. OS, doesn't matter. There are some requirements for some Autodesk products. I think Revit has you have to have Pro for some reason. Software monitor, external storage, and I think that is everything. So yeah, thank you for listening. This has been my guide to what to look out for in hardware and not really a system to build. So thank you for listening, and I'll see you next video. Goodbye.